Yo, freeze! That's a nice gritty right there. I want to find out how much his erector spinae is being used and how many compressive forces are on his spine.
In part A, we're trying to determine the tension force produced by the erector spinae muscle when a force of 55 newtons is applied to make the back rotate like this.
Pause the video, read it over, and we're going to go over the problem real quick.
We first made a diagram of the situation. The x-axis is equal to the spinal column, which is 30 degrees above the horizontal. The y-axis is then perpendicular to that. The force of the erector spinae muscle is represented by Fe, which is equal to 55 newtons and is 168 degrees in relation to the positive x-axis. Finally, the weight of the trunk is 90 pounds and is 240 degrees in relation to the x-axis. The spinal column is equal to the positive x-axis in our diagram. We need to find the x component in order to find the compression forces on the spinal column.
To find the tension of Fe, we need to fill out our y component table. To find the y component, we need to use the equation Fe sine 168, and we are told that the force is 55 newtons. If we set the sine of 168 to 55, we can then solve and find the force of tension.
For part B, we're trying to find the compression forces on the spinal column. For the first step of part B, we'll first convert 90 pounds into newtons by converting 90 times 0.45, which is a conversion from 1 pound to kilograms, then that times 9.8, which is the force due to gravity.
To find the force compression on the spine, we need to start off by finding the x component of the force applied to the spine, which we found before as 265 newtons, and the cosine of 168, and we end up getting negative 259.2. The next thing we have to find is the x component of the weight. For that, we take the force of gravity, which we just found, and the cosine of 240, and we get negative 298.45, added together for our final answer of negative 457.65 newtons.
Now that we finished the problem, you can continue, Rohan. Let's go.